The planet is heating up.
The oceans are becoming filled with plastic.
Change starts now. Change starts now.
We're on a countdown
To zero waste. 5, 4, 3, 2, 1.
This is the Zero Waste Countdown Podcast. Here's your host, Laura Nash.
What you do here at home or wherever you are in the world can really have an impact on a global scale.
Hello everyone and welcome to the ZWC. If you've been following me on Instagram, you would have seen my trip to the Amazon jungle during the fires, and what I found there was that plastic pollution has reached deep into the Amazon jungle. There was a plastic bag found in the deepest part of the ocean, Marianas Trench. We know Mount Everest has a problem with trash, and now plastic pollution has been discovered in ice cores in the Arctic. With me today is Jacob Strock from the Graduate School of Oceanography at the University of Rhode Island to talk about his research trip to the Arctic. Welcome to the show, Jacob.
Thank you. Glad to be here. Thank you for having me.
So you were part of a pretty exciting research team that went up to the Arctic, and you went up on an icebreaker. So which ship were you on and where did you go?
Absolutely. Yeah, so we were on the Oden, which was a Swedish icebreaker. And we went from Greenland and Thule all the way into the Northwest Passage in northern Canada, pushing far up into the ice, and we were looking at the marine environment around there.
Awesome. And it must have been pretty beautiful up there.
Oh my gosh, absolutely. That was definitely an added bonus, being a scientist on that trip.
Mm-hmm. That's one of my dreams. That's why I joined the Navy 10 years ago, but I actually never got up there. So one day I hope to get up to the Arctic, and there's some pretty cool things going on up there. So how long was your trip that you took? How long were you up there for?
Yeah, so we were up there for 3 weeks on the ship. Took a few days of transit to be able to get across the bay into the Northwest Passage and a few days transit back, but a majority of that time we were spending pushing into the passage, into the ice of that region, and really exploring what's happening from an oceanographic standpoint in this very dynamic and rapidly changing ecosystem.
Mm-hmm. So I grew up reading about the Arctic and the Northwest Passage, and we know that some ships back in the 1800s met with tragedy, especially the HMS Terror and Erebus that we recently found sunk up there on a research expedition. And I think we all kind of grow up thinking that the Northwest Passage is going to open more and more. So is that true? Like, is there less sea ice in the Northwest Passage most years?
Yeah, that's definitely a fear. Is that the ice cover is rapidly changing, and it depends year to year. Even as the mean annual temperature rises, and we expect to see less and less ice, it still depends on what year you go there. And even still, we encountered a lot of ice on our trip, so it's not that this region is yet devoid of life, but it is a rapidly changing ecosystem.
Mm-hmm. And what were your duties on board? Were you a scientist and you had a lab on board? Did you have equipment on board?
Absolutely, yeah. So I'm a biological oceanographer, so I was a scientist on board the ship, and we had a number of different research themes, from physical oceanography, understanding how the currents move through this understudied area, to chemical oceanography to tell us about different roles of nutrients and carbon through this ecosystem. And I was on the biologic oceanography side of things, and we were specifically looking at the microscopic life through this region, the phytoplankton, which are the plant-like plankton that, much like plants on land, they take in sun's energy and use that to make organic materials, feed the marine food web, and really keep this ecosystem running from a biologic standpoint.
So were you taking ice core samples as well, or were you specifically focused on the biology part of it?
Yeah, so from the biology part of things, we were focused not just on the ice cores, but throughout the cruise looking across at water samples. So we had microscopes on board with us that we're using to look at these microscopic algae. We were filtering for their different pigments, such as chlorophyll, which can give us an idea of how much living material is there and how it's distributed in the water column and throughout the ice environments. And we also had some nice automated instruments that took pictures, actually, of all the microscopic organisms that we passed through it. So we could get an idea of, among these diverse types of algae, what is living where, and we're trying to unravel why we see these distributions and how it could change in a changing Arctic ecosystem.
So when you were looking at any of these plankton under the microscope, were you looking for plastic?
So initially, we were looking at the plankton separately from the plastic, but Alessandra D'Angelo, who's a postdoctoral scholar and was on board this cruise as a scientist, decided that it could be interesting to really take a look at these ice cores and see what's there. And so we were already looking at some biology in that aspect, and she thought, well, so the way this ice forms is that you can imagine crystals below the surface of the water forming into the water column. And the idea is that as water passes through those crystals, it almost acts like a sieve and can collect material from the living plankton to the non-living plastics. And so that's how we got the idea to focus on the ice cores to see what could be there.
Oh, okay, cool. How deep were the ice core samples that you were taking?
These ice cores were roughly 2 meters thick, depending where we were in the passage and what type of ice we were standing on.
So you were taking the ice core samples, and then you were looking at the plankton, and then Alessandra was looking for non-organic material?
Absolutely. Yeah, so Alessandra, part of her mission, so she had multiple research objectives, but in part was looking at the non-organic material, these plastics that you might not expect to see a lot of, but after we melted down the ice, we filtered it, and we looked at it under a microscope, and we saw this abundant material that was very obviously not natural in origin. Bright colors, regular shapes that was not living plankton. It was clearly plastic of some sort.
Wow. So that's really sad because we think of the Arctic as this pristine, untouched area. So how is this plastic getting up here? Is it with the ocean currents?
Absolutely. That's one of our suspicions, is that there are people living in this area, but it's very possible that the plastics we're seeing in this region are actually coming in from other ocean basins. So these waters are connected to not just the Atlantic, but Pacific and Arctic regions, and it's possible that these plastics are coming in from other places. And I think it's really a message that even these places that seem so remote really are connected in so many ways to population centers of people around the world. And what you do here at home or wherever you are in the world can really have an impact on a global scale, for better or for worse.
Yeah, absolutely. It's something that I hear in Canada all the time is that it's not our fault. We're not the ones throwing plastic in the ocean. It's Asia. And Story of Stuff came out with a really good video saying, well, a lot of the stuff that North America uses actually gets shipped to Asia. So even if it's entering the ocean from Asia and not North America, a lot of it comes from North America, whether it's being shipped as garbage or whether it's companies that started in America that are sending things over there. So it's all of us, I think. And I was just in the Amazon and I was so shocked and surprised to see how much the local populations there use plastic and they don't have recycling facilities. So did you see that the populations up in the Arctic are using a lot of plastic too?
So that was something we did visit the communities there, and I think they do a very active job because, again, I don't want to speak for everyone that lives there, but they rely very much on the natural resources around them. And I think that there's definitely a consciousness to keep care of the resources that are there.
Oh, well, that's really good to hear. So were you guys surprised to see this much plastic in the ice core samples? Was this a bit shocking to the team?
I think on a personal level, it was very shocking to us. So we weren't the first people to ever note plastics in Arctic regions, but still for us, we had spent, leading up to our observations of plastic, we had spent several days looking out at what looked so much like a pristine environment. And all the time we would see these beautiful pieces of ice floating out on the ocean, and they just look so pristine and pure. But then when you melt them down and look closely, and you realize that even these are affected by human impacts, particularly plastic pollution.
Mm-hmm. And I've heard that it's hard to distinguish where this plastic is coming from because it's so small. It doesn't have like a label on it or anything. Were you able to tell what any types of the plastic were?
Yeah, that's definitely one of our current research interests, which is to take that plastic material we do have and perform analyses on these so we can at least identify what types of materials they are, so we know that could give us an idea of what types of pollution and maybe what man-made products these are coming from. But also the down the line concern is, what do these materials degrade into? So understanding what their composition can also help us understand, what are the dangers as they degrade chemically or physically beyond what we can see, and could that also be a threat to the marine life in this region?
Mm-hmm. And as a biologist, what do you know about plastic being a threat to biological life up there? Do you think it's an issue, or do fish just eat microplastic and then poop it out and it's not an issue, or what's going on there?
I think it's increasingly the scientific community in general is seeing that plastics are so pervasive and becoming a concern almost everywhere, and organisms down to the microscopic level are consuming plastics. And the jury is still out really on what types of effects that we'll start to see from marine life ingesting plastics, but I don't think there are any good outcomes.
Yeah. I read a study about smallmouth bass in upstate New York, and the BPA, the high levels, were, I guess, changing the sex of the male fish. I don't know if you've read that study, but I found that pretty alarming. So if there are certain chemicals, especially BPA, then that might be an issue, right, with marine life?
Yeah, that's very possible. Is, again, what do these materials degrade into? And as you mentioned, BPA, chemicals like these and others can act as environmental hormones and, possibly have very direct effects on life.
Were you finding anything that was still intact? Like, did you see plastic bottles or plastic bags or anything like that when you were up in the Arctic?
On one occasion, actually, that was so, and I was surprised. We were collecting samples over the side of the boat, and most of the time we had seen these large pieces of ice passing by, and I thought, that almost looks like an ice cube passing by, and it was a piece of bubble wrap I saw floating through the water. That also was quite alarming.
Packaging. Oh, that's very strange to find that floating around in the Arctic. My goodness. So what can you tell us about the ocean currents? Like, you said that the Pacific and the Atlantic, like, they're all reaching into the Arctic, so it kind of doesn't matter where you are around the world. If you throw a bottle out anywhere and it ends up in the ocean, I suppose it could go up into the Arctic. I guess maybe not in the southern hemisphere, or could it? I don't know. What can you tell us about the ocean currents that are pushing up into the Arctic?
So that's, I would say, something that we're still figuring out, and part of this cruise mission was to better understand what the influences of different currents and sources are in contributing to this Pacific Northwest Passage region. But I think, as you mentioned, it's really important to keep in mind that the oceans are all connected, and depending where that pollution comes from and where you are in the ocean could have a very different outcome, reach somewhere potentially very far, such as the Arctic.
Mm-hmm. And do you think that the Arctic is more at risk than other areas?
In terms of plastic pollution, or? Yeah,
like sometimes we hear that the Arctic is very delicate, I guess, because of, a lot of the Arctic tundra. And what about the marine life up there, though? Is it more at risk than other areas, maybe because there's more life still up there?
I think that part of the concern for the polar regions is that some of the large-scale climate changes that are being observed and predicted, currently those predictions and observations suggest that the polar regions will be affected to a much more severe degree than other regions of the world. So we expect more rapid climate change in these regions, meaning greater temperature rise, meaning the ice, when you spend a lot of time in the Arctic, you realize it's such a central feature to this ecosystem, and that climate change is forcing it to change very rapidly. And, also just visual observation of our time there, that a lot of the life in this Arctic region relied so heavily on the ice cover, be it the polar bears that were using it to hunt, or the seals that are using it for other purposes, to bask on, even just to take a rest, but also even down to the microscopic level, that there are specific types of algae that are important for this ecosystem that provide the base of the food web that only grow on the ice in some cases. And, once you start even just changing that one feature, it could have rippling effects through the ecosystem.
Absolutely. Do you think that this study is going to help other scientists go up there and look more into the issue of plastic in the Arctic?
Yeah, we absolutely hope so, that there's certainly an increasing awareness in the scientific community, not only that these plastics are everywhere, that they also seem to really have very pervasive effects across ecosystems and across living things. And so we hope that the research we produce here might inspire others to continue on with their work, and hopefully also think about, in these more remote regions, although they're more difficult to get to and why we don't have a lot of observations there, but hopefully that we can continue this work to study these sensitive and dynamic ecosystems.
I wonder if there's plastic like this in Antarctica. Probably.
Yeah, I think that's very possible as well. And there may already be some literature out on that, but it does pose that question that some of the changes we see in one polar are potentially also very applicable at the other.
Mm-hmm. My friend in the Navy went down there on a British ship, and he was in sea state 11. Did you guys get any crazy sea states, or was it pretty calm?
Yeah. So that was another, I guess, pleasant feature of the ice, is that it stabilizes the water a bit. And so actually passing through the Northwest Passage there, it wasn't so bad in terms of sea, and it was relatively calm. And, there was a little bit of rumbling as you're breaking ice, but other than that, it was not too bad seas, at least compared to some of the other conditions we'd been in.
I'm a pretty brave person, but I think I'd be scared being up there with just one ship and so much ice, and, watching Titanic as a little girl.
Very so.
Because there was only one ship or more?
Yeah, so we only had that one ship with us, but luckily we had a very skilled crew in the Swedish ship, and they had done many Arctic missions before, and so we were very confident in their ability to keep us safe, and we were happy to be aboard their ship.
That's very cool. So what about you? How did you get interested in biology?
Yeah, so I definitely got interested in biology during my time in college, and actually started in a different direction. I was studying biochemistry and doing research on pharmaceuticals. And then one day I had the opportunity, perhaps a bit serendipitous, to work with an alumni who was doing research on sharks. And I thought, well, how could I pass that up? And one thing led to another, and found myself here at graduate school studying for my PhD in biologic oceanography, and I couldn't be happier.
Very cool. So you were studying sharks in grad school?
As an undergrad, I was. But
cool.
Then I moved to the microscopic world. So I spend a lot of my time thinking about phytoplankton, which, again, are microscopic organisms, but they make up about half the primary production on this planet. So about half the air you breathe and about half the carbon dioxide that's taken out of the atmosphere ultimately goes to this primary production that is in the ocean. Even though most people probably never thought about it or can't see it, they're really critical to the functioning of our planet. And that idea got me really excited, and it turns out that these phytoplankton are extremely diverse. I mean, many thousands upon thousands of varieties, and so very few of them do we really understand very well. And there are so many open questions in the field, and that seems very exciting to me.
That's very cool. I will never, ever forget being on the west coast of Canada and throwing ice cubes into the water and then watching those beautiful blue, is it phytoplankton, the ones that glow?
Yeah, absolutely.
Yeah, they're amazing. And then I saw someone fall into the water. It was pretty shallow, but he was just trying to get onto a boat at night, and he slipped and fell. And And then he stood up and he was swishing them around, and it was like the most beautiful thing. It looked like he was in a universe swishing these things around. It was pretty amazing. Did you say that the phytoplankton is basically producing like 80% of our air, like in the planet?
A little less than that. It's about half the oxygen that you breathe is roughly attributable to phytoplankton in the ocean. Yeah.
Wow, that's amazing. I didn't know that.
Yeah. So absolutely, a lot of people think about terrestrial plants, and obviously things like trees,
forests,
grasses, and everything you see out your window are very important to us as well.
Mm-hmm.
But there's also this hidden side, which is all the microscopic organisms in the ocean, which, although you probably rarely see them unless they form some dense bloom, you might not otherwise be thinking about. But really, they play this crucial role for the habitability of our planet.
Wow, yeah, I didn't know that. So what can we do as, human beings to increase, I guess, like the health, like make sure that phytoplankton are healthy and that they're producing oxygen for us and living their happy lives? Is there anything that we can do?
Yeah, so I think that it's all about small steps, and it's easy to be, really off-put and maybe feel a bit hopeless when you make observations like plastic in these remote regions, and you feel like, what could we possibly do? Even these pristine environments have already been contaminated. But in reality, the way that those plastics got there was everyday choices by people of using plastic products. And really, the way that we're going to solve a lot of these environmental problems is the everyday choice of people. So just being as aware as possible of what materials you're using, trying not to be wasteful, trying to avoid plastics as much as possible. And I think if everyone makes a small contribution, it can really have a profound effect.
Mm-hmm. Yeah, that's right on the same page that I'm on, is just don't use the plastic that we don't need. There are plastic that I think we do need,
right.
In the medical community and stuff, but sometimes it's frivolous to be using certain items. So if we can just stop that, it helps. So just to go back and kind of clarify, were you able to look at the plankton and find any plastic in it, or were you finding kind of plastic separately and then the plankton separately?
Yeah, so the observations we did make were more the plastic separately and the plankton separately, although it is very possible that there is a connection there. It just wasn't something we were able to measure or observe on this cruise.
Mm-hmm. Is that something that you might do in the future, is see if there is tiny bits of plastic or toxins or something that is in phytoplankton? It seems like these are just on such a small scale.
Absolutely. I think definitely as we progress this project forward, that could be a very interesting route, is to think about how is it going through the food web, and that could lead to more field observations, so maybe centered here off Narragansett Bay, whereas our home institution, or possibly some laboratory experiments where we see if these plastic products we were observing can possibly make their way into the food web at this scale.
So you said that we should kind of think about reducing our plastic, but do you have any ideas about how we can do that? Because sometimes I look around and I see all these restaurants and grocery stores and everything, and they're just serving so much of it. And it's a tough issue to turn that around. Do you have any thoughts on how we can use less?
Yeah, well, I think maybe, for example, some of the everyday things I try to do are going to the grocery store and using reusable bags, or maybe sometimes they try and push that plastic bag on you, and you have to say, no, I can just carry it in my hand. It's only one item. So sometimes people might give you a look when you try and take that extra step, but you just have to be confident in what you're doing. And again, those small steps will make a difference.
Yeah, good for you, because sometimes, like when I started doing this, sometimes I would just give in, like after being like, no, I don't need the bag. They'd be like, no, this thing might leak. You do need the bag, even though I have a cloth bag with me. And then I just sort of like, my shoulders slouch and I'm just like, oh, defeat. Like, right. I don't know I'm not going to fight this person. So.
Right. Yeah.
So yeah, it can be frustrating.
Yeah, I think it's frustrating, and it's easy to give in because I think 99% of the time, the plastic option they make as the easier choice. So it's coming prepared with your own mug or coming with your own bag, and sometimes being a little obnoxiously persistent that you're going to use yours.
Yeah, I've been there too. I think probably all my listeners have had weird experiences like that of just trying to be very polite and just people not getting it. But we try to do our best. So, well, this is very cool. I can't imagine how amazing and adventurous it would have been to go on this expedition and make these findings. And I mean, it must have been a bit disappointing to see the plastic. Were people on the crew as well, like, disappointed? Like, were you sharing your findings with people that weren't involved with the scientific study?
Yeah, so I really, I think it was an amazing crew, and everyone on the ship, professional scientists or not, was very interested in what the outcomes were from our studies. And so people were kind of tracking what we saw through the microscope. And I think the day that we melted down our first core and saw the plastics in it, I think everybody really felt that as a little bit of sadness of like, ooh.
Yeah.
Especially because we had all grown this amazing admiration for the Arctic environment. And so to realize that what we were looking at was so heavily polluted and what seemed so pristine was really, it definitely had an emotional effect on people.
Yeah, it's like we have to curb the consumption of it and then I guess kind of worry about cleaning it up as well. Like there's these multifaceted approaches that we need to take, I think, because we do have to stop the crazy amount of tonnage that's going into the ocean. But there's going to be plastic in the ocean for a long time because where else is it going to go? Unless, I mean, it's too light to settle on the bottom, right? Like there's always going to be some in the strata, I guess.
Right. So I think different plastics have different densities, but I think there's a significant portion that is less dense than water, so it's going to stay in those upper regions of the ocean. Will possibly take a while to degrade, even if we stop pollution now, but I think the least we could do is prevent ourselves from putting more of it there.
Yes, absolutely. I'm working on that. But the photo degradation, that just means that it breaks down smaller and smaller and smaller. But like, is there a point where it does disappear?
Yeah. So chemically, there is degradation where the plastic will actually turn into other products which can be dissolved in the water, which means that visually it might not be there, but chemically it's in some other form, which in itself can also be very dangerous. I think there's still a lot of research to be done on what those degradation products are, and then not just what are they, but how might they affect the life that is in the ocean, and how might they be affecting us because we depend so much on that life. The fisheries to using it as recreational sources, and again that the ocean plays this crucial role for our climate, and as we pollute it more and more, what will happen to the life that's in it?
Mm-hmm. Yeah, it's a conveyor belt for our weather kind of thing, right?
Absolutely.
Yeah. Do you still eat seafood?
Absolutely, I do. So I know that that pollution is a problem, but that also I think fish and fisheries remain an important source of protein for people around the world.
Yeah.
And I think that also poses its own set of challenges.
Yeah, it was a big popular thing to eat in the Amazon, and I don't know if it's so weird. Like we don't know if it's healthy or not, and we're just sort of doing this experiment almost of like covering the world with plastic and just waiting to see what happens. So it's good that you're out there and working on the science aspect of it and seeing what we can find out. So thank you for doing your work, and thank you so much for coming on the show. It's been really nice to talk to you today.
And thank you for having me. And also thank you for doing this show, because this is the exact type of coverage that we need for some of these pressing issues of today.
Well, thank you so much. And I hope that our listeners enjoy the show and that we can make a difference in curbing plastic pollution now that we know that it's up in the Arctic. So thank you.
Absolutely. Thank you.
That was Jacob Strock from the Graduate School of Oceanography at the University of Rhode Island. Did you know you can now find our episodes on YouTube? If you have a YouTube account, please like, subscribe, and comment on there. And if you haven't given us a review on iTunes, Apple Podcasts, Google Play, Stitcher, or wherever you listen to your podcasts, please do so. It helps the algorithms push our show up in search results, which means more people will discover the show and more zero waste solutions will be shared around the world from our amazing guests that we've had on the show. I'm a volunteer at my local college radio station, and I don't make very much money, so if you have a few bucks to spare each month, you can sign up and be a patron on Podbean. There's a little reward button you can click on there. I'm also on Patreon, but I want to keep all my content free for everyone instead of putting it behind a paywall, so you also can donate directly on the show's website, zerowastecountdown.com. We are a registered nonprofit in Canada called the Zero Waste Countdown Initiative. Thanks for listening, everybody, and thanks to our listeners in America, Canada, Germany, the UK, Australia, New Zealand, Spain, and wherever else you're tuning in from. Together, we're going to change the world.
Change starts now.
This is the Zero Waste Countdown Podcast.